This was an integral that slid into my DMs and I just couldn't resist. So here's the integral they're trying to trick me with. We have the integral with the lower bound tangent of pi over 4. The upper bound is going to be this limit as u approaches infinity. And then we have sine squared plus cosine squared all over x plus x squared plus 1 with respect to x. And it's honestly not that difficult, very, very evil scribble coded. But let's go ahead and solve it. Well, first we have the tangent of pi over 4. Well, that's just going to be 1. So we have 1 on the bottom here. This right here, we have the limit as u approaches infinity. So whenever we have infinite limits, we just look at the degree of the top and bottom. Looks like the degree of the top is bigger, so it's going to grow faster. Therefore, the upper limit is going to be infinity. Then we have sine squared plus cosine squared. Well, that's just 1 over x times x squared plus 1 with respect to x. And I think this is the hardest part because we just have to solve this using partial fraction decomposition or try to rewrite it in a different way. And let's see, I'm almost certain then you can rewrite it like this. Give me 1 second. 1 over x minus x over x squared plus 1 with respect to x. So I sort of did that in my head. Now, if I were to just check it out and double check this, I can multiply this by x squared plus 1 minus x. Yeah, that's going to be correct. Okay, so now we just can go ahead and continue integrating. This right here will be a natural log. So now we're going to have natural log of x minus, and this you can easily solve by a u substitution, and it's just 1/2 natural log of x squared plus 1. And then we're still implementing the first fundamental theorem of calculus, so we need a 1 to infinity. Well, let's just kind of fix this right here because it's being subtracted. So I'm going to do a couple things. Because it's being subtracted, I'm going to rewrite it as a division. So x over, and then this has a 1/2, therefore this entire value is a square root. So we have x squared plus 1, and then we are still implementing the first fundamental theorem of calculus. Now, you're technically approaches infinity. You're not necessarily plugging in infinity, but if you notice the degrees, we have degree of 1 on the top, and this, though it's x squared, you're taking the square root of it, so it also has degree 1. Therefore, this right here is gonna have a limit of 1. So now we have natural log of 1 minus, and then we're gonna have, when you plug in 1, you get natural log of 1 over root 2. Wow, 1 over root 2. All right, not bad. Well, natural log of 1 is just 0, so our answer is just going to be negative natural log of 1 over root 2, and we are done, guys. That is how you solve this particular integral that someone sent to me on my DMs.